Good morning to all. In continuation of the previous lectures, I am interested to explain the formation of Newton ring by the transmitted part of the light. In this lecture, I will also try to explore the application of these expression which has been derived for the reflected and transmitted light to compute the wavelength of the monochromatic light and the refractive index of the any liquid which is introduced in Newton ring assembly. Let us start our discussion. As you see in the diagram, a incident light falls over a plano-convex lens which is resting on the glass plate at the point P, that is point of contact, and this is your plano-convex lens and this is your glass plate. Between the lower surface of the plano-convex lens, that is curved surface, and the plane surface of the glass plate, a air thin film is enclosed. When a incident light falls at the angle I at the plano-convex lens, it get multiple reflection and reflection through the air thin film, and we get the two transmitted wave which are coherent. So T1 and T2 are the coherent transmitted part of the light, and these coherent waves T1 and T2 get superimposed and results the interference pattern. So the effective part difference of the T1 and T2, so the effective part difference of T1 and T2 is given by delta effective. In general, delta effective is equal to 2 mu t cos of r plus alpha, that is equation 1. In case of Newton ring assembly, the value of refractive index is 1 because air thin film is formed. Value of r is 0 because angle of incidence is 0, and alpha is tending to 0 because r is effectively very large, that is infinite. So the equation 1 becomes delta effective equals to 2t, that is our equation 7. The delta effective is dependent on the value of t, and the value of t can be computed as using the a plano-convex lens which is resting on the glass plate, Newton ring assembly, completing the sphere of the plano-convex lens having center O, and there is a right angle triangle, that is OMN. OM is equal to R minus T and ON is equal to capital R, and MN is equal to RN. RN is the radius of the particular ring, nth ring, at the point N having thickness T. So using Pythagoras relation, ON square must be equal to OM square plus MN square. Substituting the values, and we get the value of T is equal to Rn square over 2 capital R. That can also be written in term of the diameter. Sorry, this is T. T equals to dn square over 8R. Now using equation 3 and equation 2, we get a relation delta effective is equal to 2 twice of T, means 2 times of dn square over 8R. After solving, we get the dn square over 4R, that is equation 4. Now, whenever this delta effective satisfy the condition of maxima and minima, it will give you the bright rings and dark rings. So please see, the effective part difference must satisfy the condition of maxima or minima for the bright ring or the dark ring. So what is the condition of maxima and minima? That is delta effective must be equal to n lambda, that is for bright ring, that is condition of maxima, and delta effective can 2n plus minus 1 lambda by 2 for the dark, that is condition of minima. Let's say this is equation 5. Equation 4 and equation 5, we get the dn square is equal to 4n lambda r for the bright ring, and the dn square is equal to 2 bracket 2n plus minus 1 lambda r for the dark ring. Taking the square root on the both side, we get dn is equal to square root of 4n lambda r for the bright ring, and the square root of 2 twice of bracket 2n plus minus 1 lambda r for the dark ring. That is equation 7. It is a equation 7 is used to explain the formation of Newton ring in case of transmitted light. If we observe the equation 7, it will give you the some important information. The equation 7 is called the condition of bright and dark. These conditions are just interchange the condition obtained in the reflected light. So the pattern formed in the case of transmitted light are complementary to the pattern obtained in the case of the reflected light. Therefore, we may conclude an important point here. The both pattern holds the energy conservation principle. In case of the transmitted pattern, the center will appear bright, and it has the alternative arrangement of the dark and bright ring with increasing diameter. And the other information can also be explained using the equation 7. It is note that the spacing between the two consecutive bright rings is continuously decreasing, can be understood with the help of the equation 7, and the diameter is continuously increasing with the integral square root of the integral values or the square root of the odd number in case of bright and dark ring, as well as it can help us to understand the other observation which can be made here. in the Newton ring experimental setup. Thank you all. If you have any problem, please write me. My email address is drrkp70, and I advise you, please go through the any standard book to see the more detail. Thank you once again.